So much of the verbiage and the ideas for sequences is borrowed right out of the first semester calculus course. Consider this, for example, the limit of a sequence. If you will recall the definition back in your previous calculus class, we say that a function here, let me see if I can zoom, get you to see the whole picture. There you go. That covers the whole picture. So maybe not. So in the previous class you learned that the limit of f of x as x goes towards infinity, this part is important, is equal to some real number L if and only if for every epsilon greater than 0 there exists an m that's a real number such that x being larger than m implies that the distance from f to L is less than epsilon. Duh. It's the famous definition for a limit. This is probably not the appropriate time to go over this definition. It's incredibly important. It's a cornerstone of calculus. But this may not be the appropriate time to go over it. However, assuming that you've taken a good Calculus 1 course, you already understand that definition, and we can use that for our task of the day here, is to understand limits of a sequence, because for a sequence we will define the limit of some sequence an is equal to L if and only if for every epsilon greater than 0 there exists an m that's a real number such that x being larger than m implies that the nth term of the sequence distance from that term to L is less than epsilon for all n's that are larger than, or just should have said, sorry, correction, for all n greater than m, all the terms greater than m, the nth term is within epsilon of L. Okay?